Welcome to the Digital Circuits Lab. Hope that you are safe and sound. Last semester, some of the experiments in the Analog Circuits Lab you have used simulator. This semester in Digital Circuit Lab also we will be using a separate simulator. So you need to download a simulation software called Circuit Maker. I believe some of you might already be using Circuit Maker. So today, particularly for uninitiated, I'll just show you how to use that circuit maker, and maybe in line of the first experiment that we would carry out in the lab. But unfortunately now we have to rely on the simulation itself. However, once you come back to the campus, we plan to have a couple of day workshop so that you can have some hands-on also. So now the circuit maker looks like this. If you open it in your desktop, let me just resize the windows a little bit. So if you open a circuit maker window, it would look something like this. Maybe we can see full screen. Yeah. So you have to open this file, a new file. So maybe it is calling untitled circuit, which you can rename if you wish. Now just like any other simulator, you would pick up devices, etc. So here you will use digital device. So maybe if you click on the device, then we would put that browse. Here you will find all different components. Now we will use this digital by function or by number. So there are 74 series ICs we will use in basic electronics lab, that is our introduction to electronics lab. You might have used the 7400 NAND gate, 7402 NOR gate, 7404 inverter, and so on. So here we will use the so-called TTL, that is transistor logic, which comes under this 74 series. And today we will actually use an interesting thing which is known as the 7-segment display. You must have seen the 7-segment display in many electronic instruments, in your calculators, in watches, where a figure which looks like 8, that is used to create any digit. For example, like this. So you have seen this type of display devices. So what actually is being done, there are 7 LEDs, 8 to be precise, there is a decimal point also. So if we look into that, then we will find that it looks basically like this. And here these are the pin connections shown, say G, F, etc. They are actually the name of the segment. So if you count the number of segments, there are 7 segments. This segment is called A, B, C, D, E, F, G, and the decimal points. And these are some of the pinouts. So maybe I'm showing another figure. Here these segments are named. The top one is called A, the others are named B, C, D, E, F. However, we generally prefer them to use lowercase letters rather than capital. The reason will become apparent in shortly. However, these are basically 7 diodes, or if I include this decimal point, there will be 8 diodes which are connected like this. So their anodes are connected to a common line, and that is why this type of display is called common anode display. There is a similar common cathode display also. And here these are the pin connections shown over here on both the sides, on top as well as bottom. This common, or whatever is written COM, this is basically the common line for this anode. So to lit up any particular segment, say A, we need to apply a positive voltage or high voltage at the common side and a ground or lower potential at the other side, that is at the cathode side. So I am showing another figure. Here it is given this A, B, C, D, E, F, G, these are the segment names, and here it is shown for common anode that this line should be common, and here on the other side it is shown as common cathode. So however, in this experiment we will use common anode type of display. So if we go back to the simulator, then we will find that digital by number, whenever we are going for digital by number, so then we will use today 7447. So we will come back a little later to this point. First of all, where do you get the display? So here you find that in this major device class there is display, so we pick up the display and then we will place this. Okay, so here from this I am choosing display 7 segment. Now common anode and common cathode both are there, so we are choosing common anode and placing it over here. Now LEDs, they lit up at around 1.6 volt if it is red. If it is green, maybe it will take a little bit more voltage like 1.8, 1.9. But our power supply is 5 volt. In TTL, 5 volt is equivalent to logic 1 and logic 0 is 0 volt or ground. So to have the extra drop, so how much is the extra drop? 5 volt minus 1.6 volt. I need to connect a resistance in series with this display whenever I want to lit up a particular segment or more than one segment. So how to pick up the resistor? Once again, go to device, browse, you will find resistors. So there are resistor pack or resistor, single resistor, so you will pick up single resistor and then place. But now I would like to connect it over here, so maybe I can rotate it. So if I click the mouse once, now it is rotated, so I am putting it over here. And maybe if I can zoom it up a little bit, that would be good, so that I can see it more clearly. So let me put that first here, and then I'm just pressing page up. So page up would zoom in and page down, if I press it will zoom out. So I'm pressing zoom in, or page up. Now first of all I need to change the resistor value. You can find out that around 10 milliampere of currents I want through this. So 5 volt is the power supply, minus 1.6 is the drop, so 3.4 volt remains. So 3.4 volt and 10 milliampere of current, that gives you something like 340 ohms. So I am changing this to the nearest possible value of 330 ohms. Okay, so here if I double click it, then it shows the level value, so I'm changing that to 330. Okay, so it changed the value. And now I would like to connect these 2 points, so I choose where. Here this plus sign is for where, so from one end I'm dragging the mouse to the other and then I'm releasing the mouse. So that is now getting connected. So here I need to put the power supply. There is a shortcut also, either you can go to device and then go to the power supply, and then you find that okay, there is a digital power source plus V and so on. Or else what you can do, just by pressing, there are certain hotkeys. I think the hotkeys are given over here. This hotkey is 1, as you can see. Ground is 0, plus 5 volt is 1. So if I press 1, I'm just pressing 1. Now this gives you this terminal. So if I click it, it says V1 5 volt, this plus V. So once again I can connect this plus V with a wire to this resistor. So now this connection is made. Here this display, now how it works, I have to connect the other end to the ground. You remember these diodes are common anode. So if I connect one end to the power supply, the other end, that is the cathode, I need to connect to the ground so that I can get a display lit. So how do I do that? For example, I just choose a ground. So how do I choose a ground? Device, browse, from power supply I can go to ground, or else I'm showing the other option. If I just press 0, so in my keyboard, so I'm pressing 0, a ground has come up. So I'm just putting the ground over here. Now if I take a wire, connect this wire to this segment A. Now let us see what happens. So suppose I save this one as my untitled circuit. I can give some different name. Maybe just let me put it over here. I have already done something called untitled. So maybe I would say test. So test 1 circuit, I am saving this. Now if I want to do simulate what is happening, so then simulation is having an analog mode and digital mode. So it is right now in analog mode. If I click it, you will find that now it has gone to digital mode. So let us see if I try to run whether it runs. So just I am trying to run this one. You see this segment is lit up. So that means segment A is lit up. So now I need to stop the simulation, and then I can modify this connection. How do I modify this connection? Let us say I choose this. I choose this segment. It becomes red if I can choose this one properly. So I double clicking chooses that, and then just I am clicking the right mouse button, and then I can say delete wire. Now I may connect this one. So I may reset this one because this one is still lit because of the last simulation. I can reset the simulation by clicking this. So it will reset. Now once again if I connect the wires, so suppose I connect B as well as I connect C. So B and C both are now getting connected to ground. So what will happen? The segments of LED named B and C, they will lit up. So once again let us try to simulate. So simulation, it's already in the digital mode. We have to run it, or you can press F10, function key F10 to run it, or here is also there is a figure, a running figure is there, so you can click on that one also. Now you see these two segments, these are actually two segments lit together, it is showing like one. So in that way you can lit them up. Now in typical system, what happens? You are in a digital system, so I'm just stopping it for the time being, resetting it once again. So if I reset it, now deleting the wires, delete wires. Okay, so I'm resetting it. Now it vanishes, the display vanishes. So if I am having some binary number, because in all digital systems the numbers are represented in binary, so then how do I convert a binary number into a display? Because there are 7 segments. For example, to lit up 1, you see that okay, 2 segments need to be lit up. For lighting up 2, you can find out what are the segments you need to lit up and so on. So there is an IC called 7447. So we are going to that. So say digital by number, I am choosing 74XX. Now searching or looking for 7447. So this is the IC. So I say place. So now this is, it's showing. So what it is, let us see. This IC has got 4 inputs, namely A0, A1, A2, A3. So if I apply any binary signal over here, a 4-bit binary number, so a 4-bit can have any number between 0 to 15. So for 1 decimal display, that is 0 to 9, 4-bit will be sufficient. So here if I apply any binary number from the the value of 0 to 9, then what will happen, this side you will see A, B, C, D, E, F, G. So this IC will convert a binary number into its corresponding code that I can connect to this 7-segment display for its proper lighting. So maybe I can try to connect it together. So how I can do this? Let me just check it out. First of all, I need to bring it here and rotate it. So rotation is simple. If I just click the mouse right button once, so it will rotate, or there is a rotate 90 degree. So I may use this one, and then I can drag it over here. Okay, but there is a problem, as you can see, that A is on this side, G is on this side. Here they are in the just in opposite sequence. So there will be a lot of crisscross kind of connection. So just to avoid this, it would be better if I can use a mirror version of this. So now I can use a mirror. So now you see G comes on this side, A on this side. So the connection becomes easier. So let me just move the ground connection a little bit further away, and then this one will not be exactly aligned, but to some extent. So now what we can do is to go to the where mode, connect them together. For example, this A to A. Now if I connect B to B, it appears that okay, they are having crisscross, but they are having a connection, but they are not. So I'll just show you how to untie them, but actually electrically they are not connected. Only where there is a dot there will be a connection. So I take this pointer once again and choose this first one and just drag it a little bit, so the wire connection goes like this. Choose the second one, take it a little like this to make room for others. Okay, so now coming back to the wires, so once again starting from this point and starting from, okay, that was a free form actually, so free form I am not using. So we may use auto connect from point to point. Once again it goes like this, so I can drag it a little bit. So I go to the pointer option, choose this one, drag it a little bit. So in that way you can connect. So let me just quickly connect the other lines. Suppose this is D, this is E, this is F, this is G. So let me drag them a little bit so that they don't look like jumbled up. So sorry, maybe I need to zoom it a little further to do that. Anyway, then this one, this connection is for E, this connection. Okay, now they are fine, and the decimal point I think we are not using for the time being. So one thing, that this IC they require power supply. However, here there is no power supply pin shown, but we need to have at least one power supply defined in our circuit where it is already defined. But here, as the property of this one, it is shown that this is connected to something called DVCC, digital VCC is the power supply. So here we may just connect that, okay, this is bus data, that I am connecting this one also to DVCC, and then I need to put a semicolon on this. This is required for supplying the power to this, otherwise this will not be powered up. Okay, so now let us see what happens here. Now the 7447 is connected so that these 7 segments can be driven through this IC 7447, whose inputs are this A2, A1, A0, A1, A2, A3. Now I can just maybe zoom out a little bit. So I can connect some ground and power supply over here. Now for TTL, there is a property that if I leave some connection open, it will assume high state. Why? I think that will be discussed in your theory class, so I'm not elaborating on this. Just functionally you remember that if I keep them open, so then it will be treated as a logical high or logic 1. So for example, if I once again put some ground connection, you remember how to put ground connection. If I press 0 in my keypad, there will be a ground connection. So suppose I'm putting a ground connection over here, then I'm connecting that ground to A3. So then these three connections are leaving open. So what will be the code value in this case? A3 is the MSB. So MSB is 0, other 3 bits are high. So that means the code is 0, 1, 1, 1. So let us simulate and see. So before simulation I need to save it, and then I click simulate. So 7 is getting displayed. Now I stop it. I change, first let me reset it. So 7 vanishes. Now I change the connection a little bit. Suppose I also have a ground connection from A1. So now there are two connections to ground, A1 and A3. Okay, so then what is the code? A3 is the MSB, which is grounded 0. Next one is floating, that means it will assume high 1. A1 is 0, A0 is open, means 1. So it will take a code 0, 1, 0, 1. So whose binary value is 0, 1? What binary string 0, 1, 0, 1 represents? 0, 1, 0, 1 is, if you count, it will be 4 plus 1, 5. Let us simulate and see. Yes, 5 has come. Okay, so once again let me stop it, reset it, try another connection. A0 also I'm connecting to ground. I'm connecting to this point. So now save it and simulate. So but before simulation you can predict what will be the value. So A3 is 0, A2 is 1, others are 0. So it will be 0, 1, 0, 0. What is the value? 4. Try it, simulate. Yes, 4 is getting displayed. So in this way I think we can use it. So I can stop it, I can reset it, and then I may remove these connections altogether. First of all, let me zoom in a little bit by pressing page up. So I'm removing these connections. I'm just selecting by double clicking and pressing delete from the keyboard, or alternatively say you can choose and then say delete item. The same thing will happen. Now in the actual class it will be discussed that okay, what is this RBI, RBO? This is called ripple blanking input and ripple blanking output. So I'm not showing them right now, but just to take it a little further, I'm just taking a counter. You know what is a counter? Counter is an IC which counts clock pulses. So what is a clock signal? A signal which continuously alternates between 0 and 1, that is logic low and logic high. So how we can do that? Let us take a counter device. So either I can go digital by function counters and so on, or else I can go digital by number if I know the number. So I know the number. So there are two ICs, one is called 7490 and 7493. 7490 counts up to 10 and then resets, whereas 7493 counts through all 15 values, 0 to, or rather all 16 values, 0 to 15, and then comes back to 0. So let us choose 7493 and then place it. So if I place it, now we find that there are 4 outputs, Q3, Q2, Q1, Q0. So these are the LSB and MSB and so on. So once again I think we need to understand the internal structure of that to use it properly. So right now I think I'm just showing how to use the simulator, so I'm not going into that detail right now. So I'm just rotating it. Once again the same thing is Q3 is on this side while A3 is on this side. I need to connect the outputs here, so I may mirror it once again. So Q3 comes on this side. Now I try to connect the wires Q3 to A3, Q2 to A2, Q1 to A1, Q0 to A0. Didn't connect Q0 to A0. And there is another way of using it as a bus. So later on you try to explore that. Right now I'm not showing that. It would look a little clumsy otherwise, but anyway. So now this master reset, if I keep them, this MR1, MR2, these are essentially master resets. If I keep them open, they will assume high state and it will remain in reset state. Reset means it will remain in 0. All the outputs will remain 0. So I need to connect them to the ground potential. So you remember the shortcut for ground. I'm pressing 0. So maybe I can put it here. Then once again I'm choosing where. So I'm connecting master reset. At least one of the inputs I need to connect to low, but to be on the safe side I am connecting both the outputs to low and both the master reset to low. So now these are clock inputs. So if you look into the details of this, you will find that rather than having a 4-bit counter, there are 3-bit counters together and one separate flip-flop, for which I think we need to do a little manipulation of this. So once again, maybe in your theory class or in your actual practical class it will be discussed. So right now let us see what will happen if I try to connect a clock source. So what is a clock? We have mentioned that clock is a signal which alternates between 0 and 1. So let us look into such a device over here. So there is a clock source which we will use, is called a pulsar. Pulsar will come under instruments, I guess. So choose instruments, digital. Now I'm having a pulsar. So choose a pulsar over here, place it. So what is in this pulsar? There are these two outputs. So one of these outputs, suppose Q1 and Q2 is actually inverted version of that. So anyone you can use right now. So suppose I am using this Q1 and then I am connecting it to clock 0. Okay, so then let us see what happens. I am trying to save and then simulate it. So I'm just pressing run. This side is already connected to power supply. So, and remember, this also requires power supply. Internally it is connected to power supply and ground. So I need to use, though this ground appears to be floating over here, but without this I think it don't work. But anyway, there is already a ground. So here if I try to simulate, let us see what happens. Something is happening. Okay, so but the speed is a little high, so we may not be able to understand what is happening. So let us stop it, try to see what is the property of this. So it says edit pulsar, so I'm going into this. So it is a pulse high, pulse low, etc. But here as such I think I do not have any information about this timing. So is there any other edit device data? Let us see. There is also nothing coming over here. So then what we can do? Then we can tone down the speed here. If we look into the simulation, and then you will find that okay, there are digital options. So what are the digital options? There is something called simulation speed. It is given as 30, while it is written 30 is the fastest, 1 is the slowest. So let us take it a little lower value and then see what happens. Suppose from 30 I take to half, 15. Okay, and then simulate it once again and see. Still I think it is pretty high. So can we change it further? Go to simulation, digital options, make it suppose 5. Okay, save it, simulate it. Now we can see it is alternating between 0 and 1. So why it is happening? It's a 4-bit counter. It is supposed to count from all this 0 to 15, but now it is counting only 0 to 1, because as we have mentioned that though it is a 4-bit counter, internally this Q0, this is a separate IC, I mean this is a separate flip-flop, and Q1, Q2, Q3, they are another 3-bit counter. So I need to explicitly connect the clock of this 3-bit counter to the first one, otherwise they remain isolated. So that is the CP1 is actually the clock for this 3-bit counter. So what we will do is that, I think the details will be discussed in your theory. I am once again not discussing them in detail. So I just need to connect this clock 1 to this Q0. Q0 is changing from 0 and 1. So now I come back, I save it, once again I simulate. Now you see what is happening. 0, 1, 2, 3, 4. But what is happening after 9? There are some peculiar characters. Try to see once again. Maybe it's still a little faster, so I'd stop once again, simulate, go to digital option, simulation speed. I'm making it slower, taking it to 2, and then reset it, run it once again. 0, 1, 2, now 3, 4, 5, 6, 7, 8, 9. Beyond 9 it is showing something like this kind of characters. So after some familiarization, just by looking into those characters, we know that okay, what is the code. For example, small c is something like 10, 1010. This opposite of c is 1011, and so on. Because in a digital display you need to display only 0 to 9, so you do not have to go for go beyond 9. So that is why I think we really don't bother about what is the display coming. But anyway, this is a good exercise to remember what it's coming, because then we can identify what will be the input to this. So anyway, showing this example is just to demonstrate that how to use this software, that is this simulation software, circuit maker. You can explore it. I think many of you have already explored it, I believe, for out of your own interest, but others I think use it, and maybe in your actual practical class it will be discussed that exactly what you need to do. Maybe you need to replicate this one, and also to find out what will happen with this ripple blanking input, ripple blanking output, test, etc. So right now we are stopping the simulation here, as well as the discussion. So I'm just keeping this over here, and then there are options of looking into the waveforms of these values over here. So for example, here whenever I'm running it, if I put a probe over here, you can see that it is showing that okay, it is changing from, for example, here H and L. Can you see that it is changing between high and low? Okay, so if I connect a probe here, and then I go for show waveform, then I think it will show some waveforms. That is also possible. Okay, so right now I think I'm stopping over here. You try to explore it, and then in the actual class we will explain that what are the things you need to do. Okay, so enjoy working with the simulator. Thank you.